chapter, and it's chapter 7, and it's all on some miscellaneous algebraic tools and notations. Algebraic tools and notations. So what we will be covering is 3 different sections, one dealing with something called the factorial, one dealing with summation notation, and then the other one is a partial fraction decomposition. Just out of curiosity, how many people out there have not heard of a factorial? Raise your hand if you've never heard of a factorial. Okay, so everyone has heard of a factorial, which is good. We'll go over that and review that. How many of you have not heard of or seen summation notation? Anyone that has not seen it? I guess everyone's okay? Okay, there's someone that hasn't. So we'll see that. A couple of people that may not have seen the summation notation. That's very critical in the calculus. We'll go over that today as well. And then on tomorrow, how many people know about partial or never heard of partial fraction decomposition? Or writing partial fractions? This one person, a couple people. So that tomorrow will be more of the new material. So today won't be so bad then. It'll be relatively easy for most of you. And let's start with the first thing, which is going to be factorials. So this is 7.1, it's factorials. Now, we know what exponents are. Those are repeated multiplications with the same base. And for example, we know what an exponent is and what it means. That means 2 to the 4th power. That's just repeated multiplications of the same base 2 4 times. Well, factorial also gives us repeated multiplication, but not with the same base. So factorials is a new notation to give us a different sort of repeated multiplication, which is multiplication of descending integers. So this is what it means. For example, say I wanted to express 5 times 4 times 3 times 2 times 1. So instead of the, in this case, 5 multiplications of the same base, I'm doing 5, then I reduce it by 1 to go 4, reduce it by 1 to go 3, by 1 to go 2, by 1 to go 1. That comes up very frequently, especially when you're dealing with things like probability and things like that. Those sort of multiplications come up. So what we do is we give that a special name. We call this multiplication a factorial. So we're going to give it a notation, and instead of having to write this, we would just call that 5, and we use the exclamation point. That exclamation point is read as a 5 factorial. You don't say 5 exclamation point, it's read as 5 factorial. Okay, so that's all it is. Now, in general, we can define it this way. Here's our definition. In general, a factorial is defined as n factorial, which is equal to n times n minus 1 times n minus 2 times ... And then we're going to do times 2 times 1. We've got to count all the way down. And that's for any positive integer n. So n is an element of the positive integers. We don't define a negative number n and do that. It's all positive integers. We have one other requirement for this definition, and we're going to define 0. This is our definition. That's what we define it. 0 factorial is not going to be equal to 0. That's what confuses a lot of students. It's going to be defined to be equal to 1. So if I have 0 factorial, it's not 0. It's actually just once. That's by definition. So that's how we're going to define our factorial in that way. Okay, so what we're going to do now is just do a little bit of arithmetic with some factorials. We'll compute some and then do arithmetic. That's what this lesson is mainly going to be about. Okay, so we have our definition. Let's start with some simple computations of factorials, and then we'll do some more complicated calculations with them. Things that you should be capable of doing, especially when you see them in the calculus. Since I give you that definition, these should all be simple. I would like you to try these on your own and make sure everyone's getting the right answer. Try doing some of these. And multiply it out and give me a final answer. Instead of just giving me the multiples, 4, 3, 2, and 1, give me the final answer in factorial. Just a few of those simple ones. And then you can even take a large one too. This will be a harder one. Now see if you can multiply that. Now, most calculators also have the factorials on them, so you can do that, or you can just multiply it out. But most of them should have it probably under the math mode. I don't look under it too often over here. Probably in the probability. Yes. I'll show you where it is on your calculator just in case you haven't seen it. So they grow very rapidly. So let's see what it is on the calculator. So if you have to access it, you know where it is. Hopefully everyone was able to do that without much problem. We're going to do some other sorts of arithmetic though too. So we'll show you how to simplify some expressions. I'll turn this on. Let's clear that out. So for example, say I wanted to do that 9 factorial. I might enter 9, and then I'll go over here to a math option. And like I said, it's a lot of times you'll see it on the probability. So it's one of the things under the probability menu. So you just hit number 4, and that'd be the 9 factorial. And just plug it in and get 362,880. That's all it is. So it's 9 times 8 times 7 times 6 times 5, 4 times 3 times 2 times 1. That's all it is. Something relatively simple and easy to find in the calculator. So that's something you should be able to do and be fairly comfortable with working with factorials. Now you should also be able to do it not just on your calculator, but do it yourself. Let's take a look at some more complicated expressions. Now you can do a lot of these on a calculator, but it's good to be able to do them without a calculator. So here's some slightly more complicated calculations. Some more examples beyond the basic ones. Let's say I have 16 factorial over 12 factorial. You could put this into your calculator and get an answer. But sometimes you'll see this when we're working problems to simplify them on the board. This is the algebra, if you will, of factorials. Well, what I can do is I can start to expand this out. So this is equal to 16 times 15 times 14 times 13 times. I could put 12, 11, 10, 9, but I could just say 12 factorial. And that would signify 12, 11, 10, etc. Why do I do that? Because I also have a 12 factorial underneath, and I can simply cancel out factorial. So you'll see that often done. So the final answer is just, I would take 16 times 15 times 14 times 13 and write it that way. So I take 16 times 15 times 14 times 13, and I get 43,680. That's equal to 43,680. That's all it is. I would get the same answer if I did 16 factorial divided by 12 factorial, but it shows you oftentimes you'll do that. But sometimes you might even have something as simple as this. 21 factorial over 20 factorial. Well, that's easy to write. It's 21 times 20 factorial over 20 factorial, cancel, so I don't even have to go to my calculator. It's very easy, it's just 21. That's a simple calculation to do. Now you might have something like this, and have an arithmetic inside over here. So I take, 3 times, and make it 0. 3 times 0 factorial. Well, if I do that, that's just going to give me 0 factorial, which is not 0. That's our definition. By definition, that's 1. And the calculator realizes that as well. If you put 0 factorial into your calculator, it will correctly calculate that without a problem. But sometimes we do this, especially later on, as you'll see when you go into higher math courses, you'll see it coming up and working in many different ways. Okay, so this should be fairly easy for you guys. I've seen it before. You have a calculator to do it, but the definition, what it means, becomes critical. Understanding that you can break this down into a 12 factorial and you can start canceling things. You'll see in probability, if you take a course in probability or statistics, you will see this, and we'll constantly be doing that. Relatively easy. It's a new thing that apparently every one of you are familiar with, so that's okay. That's a good sign.